Hello, ladies and gentlemen. I want to get ahead and start on tomorrow's derivatives. So I want to do the proofs tonight, and we may go over them quickly, but you'll have them on video so that you can look at them in more detail. So recall from last day that the limit from x approaches 0 of sine x over x equals 1, and the limit as x approaches 0 of cos x minus 1 over x equals 0. And Adrian, I'm looking at these ones because I'm going to use them in the following derivative proofs. You're going to remember your double angle formulas, sine of a plus b and cos of a plus b, and you probably remember these, that the sine of 2x is actually x plus x, so we can use this formula to come up with 2 sine x cos x, and cos of 2x is actually cos of x plus x, and it gives us cos squared x minus sine squared x. The purpose of today's lesson is to start working with derivatives, so we're going to take a look at the derivative of sine x. I'm going to tell you that the derivative of sine x is cos x, the derivative of cos x is negative sine x, and the derivative of tan x is sec squared x, or 1 over cos squared x. Remember what this means? This means the slope of the tangent. So that means the slope of the tangent anywhere on the curve sine x is cos x. The slope of the tangent anywhere on the curve cos x is negative sine x, and the slope of the tangent anywhere on tan x is sec squared x. Now this sort of feels kind of flat to me. I have no reason to believe this other than someone's telling it to me, so I'm going to do a proof for it. So I'm going to start off with a proof, proving that the derivative of sine x over f of x equals cos x. So we're going to let f of x equal sine x. We're going to talk about the definition. The definition of a derivative is the limit as h approaches 0 of f of x plus h minus f of x over h. In this particular case, it'll be the limit as h approaches 0 of sine x plus h minus sine of x over top of h. What we have then is, I'm going to make some room here. This is double angle formula. So I'm going to use the limit as h approaches 0. Sine of x plus h will be sine x cos h plus sine h cos x minus sine x over h. So what just happened there was I did a double angle formula on this puppy to get these two terms. Now, looking at this, I want to work this into something that I know. I see something happening here that I'm kind of excited about. Maybe you'll see it too. First of all, I'd like to rearrange these two. So I'd like to change it to the limit as h approaches 0 of sine h cos x. And then I'm going to put this one over here, plus sine x cos h minus sine x, and again all I did was rearrange these two. Now what I'm going to do is I'm going to take advantage of splitting this up, and I'm going to split it up like so. I'm going to make this sine h cos x over h plus sine x cos h minus sine x. Some of you are sitting there saying, how did he know to do that? What is he doing? What is that madman thinking? Might be what's crossing your mind. Well, let me show you. I'm thinking about taking the limit as h approaches 0 of sine h cos x over h. And I'm thinking about taking the limit as h approaches 0. Do you see the sine x's here? I'm going to common factor them out. And it's going to be cos h minus 1 over top of h. Hey, 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 do you see what I see? Do you see what I see? A limit, the limits that we know. Yes, I see the limits that we know. What we need to do is get rid of this and this. All right, so that's cos x. Cos x doesn't give a darn what happens as h approaches 0. H could stand on its head and blow bubbles for all it cares. So cos x ain't going to have nothing to do with that limit. So let's move him out. Sine h over h. This sine x is going to have nothing to do with the limit for the same reasons. It's x, not h. And we're left with cos h minus 1 over h. Oh my lord, you sent your limits to save us. Oh my lord. A little bit of Bonnie M there. I'm sure that Robbie will like it. He'll know who that is. Okay, so as h approaches 0 of sine h over h, we know that that approaches 1. And the limit as h approaches 0 of cos h minus 1 over h is 0. Adrian, that's why we did those limits. That's why I care. Oh my goodness, I'm getting very excited here. And this is going to be dun dun dun. Da-da. Cool, huh? All right, let me try something. If it goes bad, I'm going to be upset because I'll have to redo the video. But let me try something here. Let me draw a quick graph of sine. Let's make this pi by 2. Let's make that pi. Let's make this 3 pi by 2. Let's make this 2 pi. Let's make that 1 and that negative 1. So we're going to go here to here to here to here to here. Wee, 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 wee. So there's your sine curve. Let's take a look at the slopes of the tangent here. I got a slope of the tangent that is 0 here. I've got a slope of the tangent that is 0 here. So if I was to draw the derivative curve, it would go here for 0 and here for 0. Now notice that the slope of the tangent here is positive and it is decreasing. So it goes from very, very steep to less steep to less steep. Can you see it? So it's going to be something that is going to go from steep down to less steep, and that this value here is 0. So let's see, how do I know that it's steep to less steep? Well, basically, I'm going to have to prove to you that it starts at 1, but I can do that. But you can see how it comes down to 0. And then what's going to happen is it's going from 0 to get steeper and steeper and steeper and steeper and steeper to be the steepest it can be at pi. I'll have to do some work to prove to you that that'll be negative 1, but I'll do that in a minute. And then it's going to become, from here, it's becoming less steep, less steep, less steep, less steep, less steep, and it's still negative, so it comes up to here. And from here, it's going to be positive slope, getting steeper and steeper and steeper and steeper until it hits here. And look, that's the cos curve. And we started with the sine x. Now, how am I going to prove that we go up to 1 and down to negative 1? Let me think for a minute. I don't know. I'll get back to you tomorrow because I want to keep going with the videos. But we'll take a look at that.